Hello, this is question 11 on your June 2024 Edexcel paper 1. And we have design of a badge. It's this one. We have a semicircle. So this is a semicircle, center O, diameter 10. OB is the arc of a circle. This one, radius 5 and center A. So this is the arc from here. And then region R is bounded by the arc, by the semicircle, and by this straight line. And we have to find the exact area of R and write it in a particular way. So what we are going to do is to find the area of this semicircle, so all this area, and then try to subtract this one. The area of the semicircle, I'm going to write as C, is going to be pi r squared and divided by 2 because it's half the circle. And we know the radius is 5. So it's going to be 25 pi divided by 2. Now, to find this area, we have a couple of options. I'm going to show you. So remember, this is a sector because they are telling us OB is the arc of a circle. So this bit here is a sector. If we find this angle, we will be able to find this sector, the area of the sector. So this is 5 because it's the radius of this semicircle. This is 5 because this is an arc of a circle from here. So these two are 5. And this is going to be 5 as well because again is the radius of the semicircle. So we have a equilateral triangle. So all the sides are 5, which means all the angles are 60 degrees. In this question, I'm going to work with radians because it's going to be slightly faster. So 60 degrees is pi thirds, but it's really up to you to work with degrees. So what I'm going to do is I have found the area of the semicircle. I'm going to subtract the area of this sector, and in a minute I'm going to subtract this segment as well. Yeah, area of the semicircle of the sector. So I'm going to write sect is going to be 1/2 r squared theta if it's in radians. That's why I'm working in radians because it's slightly faster. R squared is 25. And then theta is going to be pi thirds. So the area of that sector is 25/6 pi. Yeah, that is this area here. If you want, we can even mark it. And now what I'm going to do is to subtract this segment. This segment, we can consider that segment is from this circle. So if you look at this arc of the sector of circle, yeah, this arc here, the area of the segment is going to be the area of the sector, which is exactly the same than this one because the radius is the same and the angle is the same, minus the area of the triangle. Yeah, so the area of the sector segment is going to be the area of the sector that we know is 25/6 pi minus the area of this triangle. Yeah, and the area of the triangle is 1/2 5 times 5 times sine of the angle in between. Yeah, minus 1/2 5 times 5, so both sides, and then sine of the angle, so sine of pi thirds, which is 25/6 pi minus sine pi thirds is √3 divided by 2. No? So this is √3 divided by 2. So we have 25/√3 divided by 4. And when we put things together, the shaded area is the semicircle, which is this one, minus the sector, minus the segment. Yeah, so I'm subtracting the pink sector and then I need to subtract the blue segment. The blue segment is this 25/6 minus 25/√3 divided by 4. And when we rearrange this, we have what we need. Yeah. This is going to be, just careful with the calculator or by hand if you prefer. We have 25 quarters √3 plus 25/6 pi which is what they are asking us. So something root 3 and b pi. A and b are rational numbers, yeah, which is what I have. Yeah, and that's all with this question. If you work in degrees, it will work similarly, yeah. So the area of the sector, remember, it will be pi r squared. So this is, it will be different. So it will be pi r squared 60 over 360, which at the end is exactly the same, is 25 over 6 pi. Yeah, that's all.